Welcome to week 2 of OPIM 201. This week, we will focus on process analysis. Understanding processes is crucial in operations management. It helps us identify inefficiencies and improve productivity. Process analysis involves examining the steps in a process. We look at inputs, outputs, and the flow of activities. The goal is to understand how a process works and where improvements can be made. First, you will learn how to draw a process flow diagram. This diagram visually represents the steps in a process. It helps identify how work flows through different stages. Next, we will discuss bottlenecks. A bottleneck is the stage in a process that limits overall capacity. You will learn how to identify this bottleneck and understand its impact on the process capacity. We will also cover how to find the flow rate of a process. The flow rate indicates how much work can be completed in a given time. Understanding this helps in managing efficiency. Finally, we will calculate process utilization and resource utilization. Utilization measures how effectively resources are used. It is crucial for optimizing performance. We will explore why understanding bottlenecks and utilization is important. Recognizing these factors can lead to improved efficiency and productivity in operations. Process capacity refers to the maximum output a process can achieve in a specific time frame. Knowing this allows us to align supply with demand effectively. When we analyze a process, we must consider its capacity. This helps us identify bottlenecks and areas for improvement. By optimizing capacity, we can enhance overall performance and meet customer needs more effectively. Consider a bakery that produces bread. The bakery has a capacity to bake 200 loaves of bread per hour. If the demand is 150 loaves per hour, the bakery can easily meet this demand. However, if demand increases to 250 loaves per hour, the bakery will struggle to keep up. In this case, understanding the process capacity helps the bakery identify the need for additional ovens or staff to meet higher demand. By optimizing their capacity, they can ensure they satisfy customer needs without delays. Managers often view processes as black boxes. This means they focus only on inputs and outputs, ignoring what happens inside. However, this approach limits their understanding. Process capacity refers to the maximum output a process can produce in a given time. Knowing this helps managers make informed decisions. It allows them to optimize resources, reduce costs, and improve efficiency. Instead of seeing processes as black boxes, managers should analyze the internal workings. This includes understanding the flow of materials, the role of equipment, and the impact of human factors. By doing so, they can identify bottlenecks and areas for improvement. The image shows a complex operation with various components. Each part plays a role in the overall capacity. By examining these components, managers can enhance performance and meet demand more effectively. Process capacity refers to the maximum output that a process can produce within a specific time frame. This concept is essential for effective planning and ensuring operational efficiency. However, it's important to note that managers do not need to be experts in engineering or the intricate details of the processes they oversee. A basic understanding is often sufficient to navigate the complexities of operations. Visual aids, such as diagrams, can significantly enhance this understanding. For instance, a well-structured diagram can simplify complex processes by highlighting key components and their interrelationships. This visual representation allows managers to grasp how different parts of the process work together, making it easier to identify critical areas that impact capacity, such as reactors, heat exchangers and compressors. In essence, while technical knowledge can be beneficial, a solid grasp of process capacity is accessible to managers. One of the most effective tools we have at our disposal is value stream mapping, or VSM. This tool serves a crucial purpose. It helps us improve processes by identifying activities that add value. Activities that do not add value are eliminated. Imagine walking through a production line. With a VSM, we can visualize the flow of materials and information, allowing us to pinpoint where improvements can be made. By focusing on value-added activities, we can enhance efficiency and reduce costs, ultimately leading to better outcomes for our organization. When we create a value stream map, we gather essential process data. This includes information about each step in the process, such as how long each step takes, where delays occur, and the total time required to complete the entire process. We also look at quality metrics, like the number of defects or errors, and assess our inventory levels to understand how much material is on hand. Resources play a significant role in this analysis as well. We consider the number of people involved in each step, the physical space required for the process, and the distance materials travel throughout the workflow. All these factors contribute to our understanding of the process's efficiency. However, a VSM is not just about creating a map. It's about analyzing it. By examining the map closely, we can identify bottlenecks and areas that need improvement. This analysis leads to more streamlined operations, and ultimately enhances our overall effectiveness. Imagine walking into a bustling manufacturing facility. Machines hum, workers are busy, and products are moving along the assembly line. But beneath this surface of activity lies a complex web of processes, some efficient and others fraught with delays and waste. This is where value stream mapping, VSM, comes into play. A tool that not only visualizes these processes, but also transforms the way we think about operations. Consider a company that manufactures bicycles. The team maps out the entire process, from sourcing materials like aluminum and rubber, to assembly, quality checks, and finally shipping. As they visualize each step, they begin to see where delays occur. Perhaps the quality checks take longer than expected, or there's excess inventory sitting idle. On one side, we have the current reality, the way things are right now. In our bicycle example, the team notes that it takes an average of 10 days from order to delivery. They also discover that 30% of their inventory is sitting in the warehouse, waiting to be used. This is a clear indication of inefficiency. On the other side, we have the ideal state, the vision of how the process should operate. The team dreams of a streamlined operation where bicycles are delivered within 5 days, and inventory levels are kept to a minimum. This ideal state serves as a guiding star for their improvement efforts. To move from the current reality to the ideal state, the team employs various lean tools and methodologies. For example, they might implement just-in-time (JIT) production, which ensures that materials arrive exactly when needed, reducing excess inventory. They could also introduce Kaizen, a philosophy of continuous improvement, where small, incremental changes are made regularly to enhance efficiency. As they work through these methods, the team might discover that by reorganizing the layout of their assembly line, they can reduce the time it takes to move parts from one station to another. This simple change could cut down on unnecessary movement and speed up the overall process. The impact of VSM can be profound. After several months of applying these principles, our bicycle manufacturing team sees significant improvements. They reduce their order to delivery time from 10 days to just 4 days, and their inventory levels drop by 50%. Customers are happier, and the company sees an increase in sales due to their improved responsiveness. VSMs empowers us to not only see the processes but to understand them deeply, fostering a culture of collaboration and innovation that drives success. Value is defined by the customer. This means that our focus should always be on what the customer finds valuable. Each activity we engage in should contribute to this value creation. A VSM helps us map out these activities in a clear sequence, illustrating how they come together to deliver value to the customer. The producer creates value through their activities. Each step in the process should contribute to this value. The term, value stream, is fitting. It encapsulates the series of actions that lead to value creation. By mapping this stream, we can identify areas where improvements can be made. It is crucial to think of the process as a stream of activity. If this stream does not flow smoothly, it can lead to delays and inefficiencies. By using VSM, we can pinpoint bottlenecks and enhance the overall process. In short, the flow must go on, a phrase you probably heard your professor say in class. VSMs are powerful. As a wise man once said, "Man who sits on rosebush gets the point." Let's break down these steps. 1. Define customer value. Begin by understanding what your customers truly value. For instance, if you run a coffee shop, customers might prioritize quick service and high-quality coffee. Knowing this helps you focus your mapping efforts. 2. Create a current state map. Next, walk through the process. For example, in a manufacturing plant, observe how raw materials move through production. Note tasks like cutting, assembling, and packaging. Gather data on how long each step takes and the quality of the output. This map shows how things currently operate. 3. Analyze the map. Once you have your current state map, look for opportunities to improve. Identify which activities add value and which do not. For example, if you find that packaging takes longer than necessary due to waiting for materials, that's a non-value added activity. Brainstorm actions. Engage your team in discussions about how to eliminate waste and add value. For instance, if you notice delays in the coffee shop during peak hours, brainstorm ideas like adding more staff or streamlining the ordering process. 4. Create a future state map. Visualize the desired state. Using the coffee shop example, you might want to show a process where orders are taken on tablets, reducing wait times. This map outlines how you want the process to function after improvements. 5. Create action plans. Finally, develop specific steps to achieve your future state. Assign responsibilities and set timelines. For example, if you decide to implement tablet ordering, assign a team member to research options and set a deadline for implementation. By following these steps, you can create a VSM that enhances efficiency and adds value to your operations. At the supply chain level, we define the scope of the supply chain. We identify the key players involved. This includes suppliers, manufacturers and distributors. We also establish performance measures. These metrics help us understand how well the supply chain operates. The functional level focuses on the functions within each player in the supply chain. We define the roles and responsibilities of each function. Performance is measured at this level as well. This helps us identify areas for improvement within each function. At the process level, we dive deeper into the processes within each function. We outline the specific steps taken to deliver products or services. Understanding these processes is crucial for success in the market. It allows us to pinpoint inefficiencies and areas for improvements. These are key material flow icons in value stream mapping. Manufacturing process. This symbol represents the steps involved in production. It shows how raw materials are transformed into finished goods. Outside sources. This symbol represents the activities that have been outsourced to another organization. Data box. This box contains important metrics. It includes cycle time, setup time, and scrap rates. These metrics help assess the efficiency of the process. Truck shipment. This symbol indicates the transportation of goods. It highlights the movement of materials between locations. Supermarket. This represents a storage area for inventory. It acts as a buffer between production and customer demand. Don't forget to check me out. Cheeky smile. Buffer, or safety stock. This symbol shows extra inventory. It helps prevent stockouts during fluctuations in demand. Inventory. This symbol represents the amount of stock on hand. It helps track how much inventory is available at any time. Finished goods to customer. This shows how products are delivered to customers. First in, first out sequence flow. This symbol illustrates the order of operations. It ensures that the oldest inventory is used first. Physical pull PR withdrawal arrow. This arrow indicates a pull system. It shows how production is based on actual demand rather than forecasts. Push arrow. This arrow indicates a push system. It shows how production is based on forecasts rather than actual demand. These are key information flow icons in value stream mapping. Manual information flow represents communication that happens without technology. Electronic information flow indicates digital communication methods. Signal Kanban, used to signal the need for more materials. Load leveling box helps balance workload across processes. Sequenced pull Kanban ensures that production follows a specific order. Withdrawal Kanban signals when to withdraw materials from inventory. Production Kanban indicates when to produce more items. Kanban post, a physical or digital board to track tasks. Weekly schedule displays planned activities for the week. Go see production scheduling encourages managers to observe processes firsthand. Under general icons, Kaizen represents continuous improvement efforts. Operator indicates the person responsible for a task. In this VSM, we see a manufacturing plant's operations. The plant sources materials from suppliers. It has a weekly production schedule. The goal is to meet customer demand efficiently. By understanding this, we can pinpoint bottlenecks and inefficiencies throughout these processes. Analyzing each step allows us to enhance productivity and ultimately improve customer satisfaction. As we continue our studies, I encourage you to think critically about how these processes interconnect, and how we can apply VSM to optimize operations in real-world scenarios. If you enjoyed this content, please consider liking and subscribing. Thank you.